Good afternoon, everyone. Welcome back to the class on database management systems. Now, you all might have gone through database management system at some point of your college career, or maybe you might have done a course on something. Okay, so database management system is a very important aspect from building applications, right? There are a lot of uh, advantages of building database management systems, especially in today's world where there are a lot of data is being generated, and the data is being used for making a lot of decisions. Database management systems are very important. Now, database management systems have also evolved from traditional database management, traditional RDBMS, to distributed query engines, where you can basically query on millions and millions of records in less than a second, right? So here, this particular sessions on database management system will allow you to equip yourselves on the skills required for creating a database, managing a database, right? Querying a database, querying data from multiple tables, getting the required information, right? So whenever we talk about database management systems, there are two things here. One is we will have to bring some interesting things from the data, and there is also something called as information. So there is something called information, there is something called as interestingness. Okay, so we will now, so database management systems are used to store the data, right? They are used to store your data, right? They are used to effectively store your data, right? And efficiently retrieve. So we'll have to store the data effectively, and we should be able to retrieve the data efficiently. What does this mean? This means we need to store the data in such a way that we store the data in an optimized way, meaning we should not be so there should not be any data repetitions or data duplications. When we say efficient retrieval, we should be able to retrieve the data with much speed, and it should not have any crashes, or it should not. You cannot say that the data is not available right now. Okay, that's basically the purpose of bringing up a database management system. And another important aspect of database management systems is, although database management systems can provide information, we also require some interestingness from the data. Okay, now let us try to understand what is interestingness in data. Okay, now let me stop the sharing for a minute. Okay, so here, just give me a second. So okay, now can you give me some examples of interesting data? Can you give me some examples of interesting data? Can you give me some interesting information from the data? Any data that you have? You would have gone through a lot of interesting data in your uh, type. So what I am doing is, I am going to show you a small piece of data. Okay, I mean, the data can be in different forms. Okay, data can be in different forms. Okay, data can be images, data can be tabular data, data can be text. But usually, database management systems is basically a tabular data. But right now, I'm going to show you an example of a data. Can you just read now here? Uh, Okay. So from this line, there is a great deal of information as what youth can do. It given if given a chance, and though it starts out somewhat often. Okay. Wait. Hmm. So just read this paragraph. Read the first few lines of this paragraph and tell me what is the interesting thing that you find out. Okay. Now, from here, and I'm showing you the text here. If you can just read out this particular paragraph, okay, and tell me what is the interesting thing that did you noticed here. So I'm just trying to find out information with respect to interestingness. So database management systems, okay, though the primary aim is to store and retrieve information. Another important aspect of a database management system is to find out interestingness in the data. Now, can you just go through this 1, 2, 3 paragraphs? Let's say first 3 paragraphs, and tell me what is interesting about it. I kept my screen open. Okay, we come back to the screen again. Somebody has found any interesting thing? You can tell me. Maybe you can raise your hands or somehow you can tell me. I'm giving you some data, right? I'm giving you some data. Can you find some interestingness in this data? Has anybody found anything interesting in this data? You're all able to see my screen. Let me see if somebody has come out. Don't you find anything interesting in this? To read the text, it's a very dull text. Okay. You all know what are all vowels? You know what are all vowels? Giving you a clue. You know what are all the vowels? In English alphabets, there is something called vowels. Do you know what are the vowels? What are vowels in English language? You can use the QA box to type it. What are the vowels in English language? There are 5 letters, right? Which you call it as vowels. Can you hear me? You're all able to hear me? A-E-I-O-U. Okay. Somebody said A-E-I-O-U. Okay. Can you use that as a clue? Can you use that as a clue and find out what is happening here? Can you use that as a clue and find out what is happening there? Can you find out what is happening there by using the A-E-I-O-U? So if you look at this text, can you find A? Can you find A in this particular, the letter A in this text? The letter A. Do you find the letter A in this? Tell me what letter you don't find. Tell me what letter you don't find. Showing you the text. Go through it and find out what letter you don't find. Tell me what letter you don't find. Somebody wants to answer? Hey, what letter is not there in this particular one? Very simple. A is there. You can see A is there, A is there. What letter is not there? What letter is not there? You all hear me? You're all there? You all had a nice lunch? Feeling sleepy? Simple question I've asked. What letter is not there in these paragraphs? Just until somebody answers, I'm not going to proceed. From this paragraph, 1, 2, 3 paragraph, what letter is not there? Pa. Finally, Loga Sundaram. Thank you, Pa. Yes. So if you look at this entire text, right? This entire text, there is no letter E. Not only in this paragraph, in the entire book, there is no letter E. There is a book called Gatsby. It's a book called Gatsby. This book contains a story of over 550,000 words without the using letter E. Somebody by name Ernest Vincent Wright, right? He wrote a book in 1939. He wrote a book in 1939. The book does not contain the letter E. That is interestingness. If you ask me for information, so there are 50,000 words. That is information. There are 50,000 words that are information. Now I can find out how many 4-letter words are there, how many 5-letter words are there, how many 6-letter words are there. What is the word with the maximum letter? What is the word with minimum letter? Right? What is the word with maximum number of vowels? All these are information. Now the interesting thing about this entire book is that it doesn't contain the letter E. Similarly, database management system is all about finding information and interestingness in the data by efficiently storing the data. That's a very informal definition. But let us go into a very formal understanding of the database management systems. Now, you all know what is a data. Data means some facts that can be recorded and that have implicit meaning. Okay. Now, what do you mean by that? For example, name. Name has an implicit meaning. Age has an implicit meaning. Meaning you don't need another word. Implicit meaning means you don't need another word to explain that. You don't need another word to explain that. Okay. For example, if I say name, Name means, yes, it is name. You all know what it is. Age, right? City, right? That's basically a data. In other words, data is information. Data is information. Uh, what are all the systems? In day-to-day life, we use a lot of DBMS systems. Example, banking systems, library systems, your contact list, right? The accounts ledger, the inquiry system, the billing systems, the hotel management system, and so many things. I mean, can you tell me any software which doesn't use database? Can you tell me any software that doesn't use database? Can you tell me a software that doesn't use database or that does not require database, in other words? Can you tell me a software that doesn't require database? Can you tell me a software that does not require database? MySQL. MySQL is a database. MySQL is a database. My question is, can you tell me any software that does not require database? For example, your your MS Paint won't require any database. Your Notepad won't require any database. There are very few softwares which doesn't require databases, but on top of that, a lot of applications which definitely require a database. Okay, what is a so we use a database management software. So what is a database management software that we use? In this training, you will be learning about Postgres SQL. Postgres SQL is a database management software that you will use. Okay, what is the purpose of this software? The purpose of the software ensures persistence, okay, data persistence. So what is data persistence? Suppose, for example, you go to any Amazon or any other shopping website. You try to buy a product, right? Whatever information you give, that information will remain. It will persist. Okay. The purpose of a database management system is to have data persistence. That means the data will exist forever. Okay. You can use any program to basically manage that software. Okay. And there is also something called as the life of data. The data, whenever you take a there are certain data which are constant data. There are certain data which is variables. There is certain amount of data that is stored in the secondary storage. For example, if you take up the constants, for example, the country codes. Okay, the country codes are constants. For example, India's country code is +91. It's a constant. America's country code is +1. That is a constant. Okay, it doesn't change. Okay, or even if it changes very rarely, but it's all constants. Similarly, there are certain things which are variables. Variables means they are the values which change over a time. For example, if you can have a variable called age, right? If I enter the age, I will give a different age. Okay? Or my age next year will be different. My age next year will be different. That is why it is called as a variable. And there are certain type of data which is stored in the secondary data. Constants and variables are only stored during the program execution. Once the program execution is over, you will not be able to access these variables. But if you store the data in a physical file, if you store the data in a physical file, or the physical file means disk, okay, your hard disk. Hard disk is nothing but your secondary storage. Okay. So the data can be a constant, the data can be a variable, or the data can be a permanent storage that is on the hard disk. So, for example, we need to analyze that for how long we want data to be persistent in the memory. Data persistence is the life of data. Sometimes we need data beyond the life of the program. So there are certain data which we will require only during the program execution, and there is some data which we will require after the program execution is over. Okay, so whatever data that is required after the program execution is over, that will be stored in your database server. It will be stored in your database server. Data is sometimes needed to remain available even beyond the life of the program, even after the program is over. For example, you are you're calculating the let's say there is a software, okay, where you are generating a transaction ID. Okay, you are generating a transaction ID. The transaction ID is generated by the code. Okay, but the transaction ID is required even after the program execution is over. I need the transaction ID to be stored, right? Then we will store that in a secondary storage, or which is also called the database. Okay. In such case, data is stored in a secondary storage like a hard disk. When data is stored in a secondary memory, it is bound by the it is bound to reside in a file. All the data in the secondary storage will be stored in a file. Okay, file is an operating which makes separation among bundles of heterogeneous data stored in storage. Heterogeneous means different types of data. There is some image data, there is some textual data, there is a tabular data, there is a music data. So there are different files, right? All these files are separately stored in different files on the hard disk. Now, when the data is stored in a file, okay, it will be difficult for us to access it easily and quickly. Okay, it will be difficult for us to access it easily and quickly. That is why we require something called as a database. Okay, so why shouldn't we store the data in a file? Okay, when you store the data in a file, retrieving will become difficult. Optimizing the file contents might be a challenge. But whereas when you use a software system like a database, okay, database software system, for example, in our case, PostgreSQL, okay, a software applications most of the time required to store relevant information in secondary storage. Internally, it will be stored in the form of a file. Internally, it will be stored in the form of a file. But what happens to the outside world? It will be managed by the database management system. A database is a place where all your application related data is stored. A database management system is something, or a database is a place where all your application related data is stored. Once application data is stored, one application data is stored in a bunch of files. We can say database is a collection of files. Database is a collection of files where using which we can efficiently store the data. Sorry, we can effectively store the data and efficiently retrieve the data. Now, in a regular thing, data will be um, uh, files needed to be handled by a set of programs. Okay, this bunch of program is a part of the actual application. So you have some application where you have a user interface, some data processing happening, and there is some file handling happening. After all of them, they're all stored in the database, which is a secondary storage system. DBMS is database management system. It is a collection of programs that enables users to create and manage the data and maintain a database. So a database management system is a general purpose software system that facilitates the process of defining, constructing, manipulating, and sharing databases among various users and applications. Very, very important point here. A database management system is a general purpose software which helps in defining the data, generating or constructing new data, manipulating the stored data, and sharing this data across multiple users and multiple applications, multiple users and multiple applications. The database architecture can be divided into two types. One is it can be a two-tier client server application, and the other one is a three-tier client server application. So uh, a two-tier client server application means you have a client and you have a server. A client and you have a server. Whereas a three-tier application means you have an application server in between. That means you have client, you have an application server and the database server. Now, what is the usage of, how is, um, uh, see, there is a two-tier application, and how is the three-tier application beneficial or better than the application server? Now, in this, see what is going to happen here is, now what we can see, think of it like this. Okay, the client is giving some data. I want the data to be logically manipulated and then stored, or I want certain conditions to be put, not just one condition. There are several conditions that I want to put so that the data is shown in a different format. Now, when you have a two-tier application, the business logic cannot be written. The purpose of having an application server is to write the business logic. So the application server helps you to write business logics. You can write logic in such a way in what format you want the data, or in what format you want to store the data. So that kind of information, that is where you will have the application server coming into picture. That is where you'll have the application server coming into picture. So if you just look at the this server, the database server, sorry, in two-tier application, you have a client and the database server. So you directly interact. The client will directly interact with the application server. Sorry, directly interact with the database server. There will be so many challenges in that case. The data formats we cannot get in the right way, or security, which user can see what data, right? That security restrictions cannot be applied. So all these kinds of security restrictions can be applied when you have a application server in place. So here you can look at this. In this model, data is organized in a two-dimensional tables called relations. See, in a database, okay, each table is called as a relation. In a database, each table is called as a, see, now let us try to understand it like this. I'm just giving you an example. See here. Now, let us assume, okay, the sheet name, okay, employee, EMP details, right? Then company details, then vendor details, right? Accounts, client details, right? So each one is a table. Okay, so employee table, I have data like EMP ID, EMP name, right? Age, salary, right? Then I have company details. CID, company ID, name, years in service, right? Revenue. This is one more table. Okay? This is one table. This is one table. Like that I can have another table. VID, vendor ID, V name, address, city, right? Uh, some details. So each one is a table. So each table we will call them as relations. Now, for example, if I go to PSQL, okay. Hope you all have installed PSQL locally on your machine. So here, if you look at this, I'm opening Postgres on my laptop. So if I say /L, it will give me the list of tables that I have. It will have list of tables I have. Now in this, if I go to the table /C / how do you connect to a database? So now see, you have connected to the Postgres. Once you have connected to the Postgres, if you want to find out the list of tables, list of databases, you will say /L. Say /LL. Sorry, /L will give you the list of tables. Sorry, the list of databases. Suppose if you want to connect to a particular database, for example, I want to connect to a database called new DVD rent. Now I say /C, that is /connect DVD renter. Now I have connected to all the tables. Now I have connected to the new DVD rental. Okay. So I've connected to the database new DVD rental. So if I go and say /D, see, these are all the tables that are present. These are all the tables that these are present. Each table is called as a relation. Each table is called as a relation. Each table is called as a relation. Okay. Now if I want to see that this table, I'll say /D actor. So these are the columns in the actor database. These are the columns in the actor table. These are the columns. So actor is a relationship. It is also called as a table. So table is also called as a relationship. Going back to the slide. Table in a relational model is a relation. Okay. So each table is a relation. So you are now seeing in the front end, you are seeing it as a table. But in the database management system, at the end of the day, in the backend, will store it as a file. Meaning, see here, when I'm querying it, I'm seeing it as a table. Okay, just select star from actor limit 5. Okay? So it is now showing me 5 rows. For us, it is like a table, but internally, it will store it as a file only. Okay. For example, in this case, if I just go to the database, my C drive, program files, Postgres SQL, bulb, data, um, see, internally, it will store it as a it won't show the name. Okay, it won't show the name, but it will internally yeah. So here, if you just go there, for each one of the table, it will create a ID automatically. Okay. We will not know it. Okay, we will not know it. Now, for example, what I am doing is now, see here, create now. Just understand here. Create database upskill. Now a new database is created. Now if I go to the location where I installed, see, you see a new folder getting created. Now this is the folder where this data, say, by now, I mean, it is actually empty, but I'm just telling you, right? So now at 4 at 2 6, a new database has been created. It will not show the same name. It will internally manage it. But what I am trying to tell you is that the data is stored physically only. Though you will see it as a table, physically all the data is stored as a physical file only. Okay, but the software, the database management system software, will efficiently retrieve the data and show it to us. Okay, an RDBMS. Okay, relational database management system is a database management system based on relational model introduced by E.F. Codd. There's a scientist called E.F. Codd who framed the rules for a database management system. Okay, in a relational database, data is represented in terms of tuples, okay, or rows. What do you mean by tuples or rows? See, this one row is a tuple. This one row is a tuple. Okay, and one row is one tuple. Okay? This is one tuple. This is one tuple. So instead of saying it as row, we call them as tuples. Okay. Some people might call it as tuples. It's all one and the same. Okay. So each row is actually a tuple. Okay. Then this is a column. Like actor ID is a column. Okay. So this is a cell. That is one a row in a particular column. A row in a particular column is called as a cell. Go back. So what is a table? A table is a collection of organized set of tables from data which can be accessed easily. Database is a collection of tables. So under one database, there will be several tables. Okay. A table is a collection of data elements organized in terms of rows and columns. Right? A record. A single entity in a table is called as a record or a row, or it is also called as a tuple. Okay. A field. A table consists of several records. Each record can be broken down into several. So this is a field. Okay. So if you look at this, each one of this is a row. Okay. This is a row now. Okay. This row can be divided into 4 fields. This is one field. This is one field. This is one field. This is one field. And also called as cell, but in a very standard terminology, this is called as a field. Okay, so we will discuss about the keys, the database keys in tomorrow's class. So in today's class, what we have seen is we have seen what is a database. Okay, what is interesting information, what is interestingness, and what is information. The difference between information and interestingness. So we found out difference between interestingness and information. Then we understood what is actually a database. Okay. Then we saw some commands to list the tables, connect to a database, and see the relations. We understood that in a relational database management system, each table is a relation. A table is comprised of rows and columns. Each row is basically called as a tuple. Each tuple or row can be further broken down into something called as fields. Okay. So we have also seen that though to the software shows the data as a tables. Internally, these are all stored as internal files, physical files. We saw that by creating a table. So when we created a database, we saw a folder getting created. If you create a table, you will see a file getting created. Like that, data will be created. Any questions? Any questions? Rajesh, you can stop recording.